There are lots of explosive, very high energy events that happen in the universe that give off in the X-ray and gamma ray radiation, among other things. One particular high energy group that we're looking at is gamma ray bursts, or GRBs. These happen in two ways. Either we have the death of a very massive star, 40 times the mass of the Sun, or we have an explosive combining of two very dense stars. Kim is actually going to tell us a little bit more about GRBs.
Gamma ray bursts, or GRBs, are some of the brightest, most energetic explosions in the universe since the Big Bang. And because of this, they're some of the most distant objects that we could see. They're called gamma ray bursts because most of the early emission is in the gamma rays. And gamma rays are a high energy type of electromagnetic wave. To put the energy into perspective, one GRB would be able to boil about 400 million kettles. So that's a 4 with 38 zeros after it. As well as the gamma rays, GRBs also emit in X-rays, ultraviolet, optical, and sometimes all the way to radio wavelengths. In 2008, there was a GRB detected that was so optically bright that if you'd been in a dark area, looking in the correct direction at just the right time, you'd have been able to see it with the naked eye. GRBs are known as gamma ray bursts because the gamma ray emission is over quite quickly, usually within a couple of minutes, but sometimes even in just less than a second. The energy is not given out in all directions simultaneously, but rather it's beamed in a jet, making GRBs a bit like a cosmic torch. So here's an experiment you could do at home. So if you have simply a torch or a mobile phone with a torch on, if you look directly into the light or shine it at a friend, look directly into it, then, well, obviously you can see the light. However, if you move it away to a different angle, then you can no longer see the light. This is basically what we find with GRBs. If the jets are pointed towards us, towards the Earth, then we detect a gamma ray burst. However, if they're offset by more than a small angle, then we don't see it. So a gamma ray burst has gone off, but we have not detected it. The SWIFT satellite was designed to detect and follow up gamma ray bursts, and since its launch in November 2004, it has completely revolutionised what we know about these fascinating objects.